Hello, GCC. We are continuing in Chapter 10. This is our fourth video in Chapter 10, talking about moles. We've done some mole calculations so far, and we're going to continue to do some more calculations now. We are going to talk about a mole ratio. So this is new. Let's look at moles of an element in a chemical formula. For example, the chemical formula is NH3. You can see NH3 up here. And what does that tell us? Well, it tells us there's one atom of N, nitrogen, and three atoms of H, hydrogen, in one NH3 molecule. It tells us that. But again, atoms and molecules are so tiny, we can't hold them, right? They're too small. So instead, we're going to deal with moles. So NH3 also tells us 1 mole of nitrogen and 3 moles of hydrogen are in 1 mole of NH3. Okay, so we're going to use those 3 and 1 numbers to make mole ratios. If you look down here at the bottom, we see some example mole ratios regarding the formula NH3, which is ammonia, by the way. Ammonia. Pew, stinky ammonia. NH3. So we can see these ratios right over here. We have 1 mole of NH3 over 3 moles of hydrogen. That's a ratio from NH3. 1 mole of NH3 contains 3 moles of hydrogen, so we can make a ratio out of that. The middle ratio, 3 moles of hydrogen over 1 mole of NH3. So we just flipped it. So depending on what's canceling out is what goes on the bottom. All right, then the last mole ratio is 1 mole of nitrogen over 1 mole of NH3. So that's a 1 to 1 mole ratio. The others were a 1 to 3 and a 3 to 1 mole ratio. So mole ratios can be written and help us do some simple problems like these. We're going to look at moles of a compound and calculate the moles of the element that's in that compound. So these are pretty easy and fun. Number 1, how many moles of aluminum are in 2.75 moles of Al2O3, aluminum oxide? Start with what you're given, 2.75 moles of Al2O3. Now we're trying to find moles of aluminum. So let's look at that formula. How many aluminums are in Al2O3? If you said 2, you're right. That's it. There are 2 moles of aluminum in 1 mole of Al2O3. So we're going to use that mole ratio and put it in parentheses with a line through it like any other conversion factor, and we will find our moles of aluminum. And it looks like this. 2.75 moles of Al2O3. Then in parentheses is our mole ratio. There are 2 moles of aluminum in 1 mole of Al2O3. Moles of Al2O3 cancel out top to bottom. We're left with moles of aluminum. What did the question ask? Moles of aluminum. So we're good. So it's 2.75 moles of Al2O3 times 2 moles of aluminum divided by 1 mole of Al2O3, and that equals 5.50. You need the 0 there because it's 3 significant figures. 5.50 moles of aluminum is our answer. So these mole ratio problems are really easy. I want you to do number 2 on your own. Hit pause and do number 2 now. You got this. You can do this. All right, number 2. How many moles of hydrogen are in 4.22 moles of H3PO4? Start with what we're given. 4.22 moles H3PO4. Now, how many moles of H are in H3PO4? If you said 3, you are correct. There are 3 moles of hydrogen in 1 mole of H3PO4. So that is our conversion factor in the parentheses. And it looks like this. 0.422 moles H3PO4 times 3 moles of hydrogen in 1 mole of H3PO4. Moles of H3PO4 cancel, and we're left with 1.27 moles hydrogen. Pretty easy problem. All right, We are done with this video. See you next time, GCC. Bye.